Hello everyone. So let us start with the next type of problem. So here in this problem, they've asked you to analyze the continuous beam by slope deflection method. If joint B sinks by 10 mm, given EI is 4000 kilonewton meter, and draw bending moment and shear force diagram. I'll also draw the elastic curve of the beam. Okay, so this is a type of problem wherein they have asked you, they're told the supports are sinking. And you can see here, the support B is sinking by 10 mm. Okay, so, and they've also given you the value of EI. All right, so this is a continuous beam wherein end A is fixed and B and C have the roller support. And span AB has 20 kilonewton per meter load, that is a UDL, and the BC has a point load which is exactly at the center. Okay, now in this they have asked you, it is a sinking type of problem, so it is very different from the previous problem. So it is sinking time, so everything would be same, but there will be additional EI values you have to substitute. Okay, okay, so you can see here. Now, as usual, first we'll calculate the fixed end moments. Now, to calculate the fixed end moments, it is same like before. It is same like before. That is MFAB, MFAB and MFBA. Okay, so MFAB, it is a UDL. So UDL, MFAB is equal to, as usual, WL square by 12. All right, so this is minus. First sign is minus. Then MFBA. So BA is plus, that is plus WL square by 8. So if this is minus 106.67, so this would be plus 106.67. All right. Then MFBC. MFBC is, again, there is a point load which is acting exactly the center. So the formula is first, because it is BC, so it is minus WL by 8, and MFCB is plus WL by 8. So it is minus 40 plus 40. Okay, this would be same. Now what changes happens is in this second part, the second step, that is slope deflection equation. Now you can see here MAB first, as usual, MAB, the slope deflection equation, right? This slope deflection equation, that is MAB is equal to MFAB plus, first write the formula, 2EI by L. Then A is the first point, so 2 times theta A plus theta B minus 3 delta by L. Now, whenever they ask you the sinking of the support, this parameter should be considered now. So all this time before, what we have done was, we used to only ignore this because there was no sinking of the support. But now, because there is a sinking of support, we need to consider this. All right. So, as usual, first MFAB minus 106, we have found out this, plus 2EI. So here you can see here, I is 2 times I. So it is 2E 2I divided by L, okay, into, open the bracket, 2 times theta A plus theta B minus 3 delta by L. Okay. Now, so I becomes 2E. So 2 2s are 4 EI. Length is 8 meter. So write this length 8 here. Then theta A is 0 because it's a fixed support. Then plus theta B minus, okay. Now how to analyze this is, so what we have studied previously was, when the sign conventions, in the first class, the start of the chapter, we have taken the sign conventions. Okay, you can see here in the sign conventions. Okay, in the settlement is nothing but, it's also called as sinking. So here, if the, so this is a continuous beam now, ABC. Okay, so you can see here, if the right side support, so always this is left and this is right. Okay, whenever considering the two span, one is left, one is right. So in this problem, you can see here, this is left and right. If the right is sinking, if the right support is sinking, then it is plus delta. That means the sinking, that means the delta value, you should consider it as plus. Similarly, if the left support is sinking, the left support is going down, then it is minus delta. This is very important. See here, both of this, initially it is all in the straight line here. Okay, when there is a sinking, now again in the question they have told support B sinks by 10 mm. So it's like this. Okay, the support, it changes position from original B to B dash. So this support is going down, it is sinking, it is settling, it is settlement happening. So that's why you have to consider this extra delta here. So it is again simple. Whenever, remember just one thing, when the right support sinks, it is plus delta, the positive value, delta should be positive. And when the left support sinks, it is minus delta. Okay. All right. So with this, okay, so let us apply the same logic here. Okay, first MFAB, we already know this. Okay, now when you consider this, now it is like this, B is sinking, right? B is sinking by 10 mm. Now consider only left part of this. So left part of B is BA and or AB. So now with respect to, now in this AB span, left support is straight, right support is sinking. So because the right support is sinking, it is plus delta. So I'll write it here as theta B minus 3. Instead of this delta value, you should substitute 10 mm. Okay, now see here, this mm we are converting into meter because all the values here, see here, this distance is in meter and this is also in meter. So we will convert this. Okay, so now this will be 10 divided by 1000. So it is 0.01. Okay, so 0.01 is nothing but sinking of the support, which is expressed in terms of meter. So it is 3 into 0.01. Again, 0.01, I have taken it positive. Why I have taken positive? It's because right support is sinking. When you in the AB span, right support is sinking. Because right is sinking, this value is positive, divided by 8. Okay, close the bracket. Okay, now be careful when you're multiplying this. Okay, whatever I've written here in red, you should do the calculation according to that only. I'll tell you the reason why also. Okay, now see here, minus 106.67 plus 0.5 EI theta B minus, okay, what you have to do, 0.5 into 3.75, multiply as it is. Okay, just multiply this and keep it in terms of EI value. Now the final form should be, don't consider this, okay? The final form should be MAB, this value, keep it in EI. So what I have done here was, in this step, I had multiplied with this EI value. Don't do that because this also will be treated as unknown only. We'll eventually substitute that later when you're solving in the calci. So now the form should be in this only. Let's see here. It is minus 10.67, 6.67, 0.5 EI theta B. This multiplied value, keep it here, 1.875 into 10 to the power 3 EI. Okay, so keep it in the order now. The first parameter should be, the first value should be theta. So the next unknown here is EI, that means this delta value. So this is the settlement value. So this is also unknown only, keep it here like this. So it is 1.875 into 10 to the power 3 EI is equal to, so then keep it in the equation form. So constant, send it to the right hand side. So right hand side is 106.67. Okay, so first equation you have got. Similarly, calculate second equation. This MBA is equal to MFBA plus, again substitute all the values, 2EI. Instead of I, again it is 2 times I. Then theta A plus 2 times theta B, because B is the first term. So 2 times theta B minus 3 delta by L. So again substitute all the values, it would be same. Theta A becomes 0 because it is a fixed support. Then minus 3 delta is again 10 mm, convert into this thing. So again, now again in this BA also, if you check, support B is sinking only, so you have to consider it as positive value only. So it is again plus 0.01 divided by 8. Again multiply this with the same way, so you're left with EI theta B minus 1.875 into 10 to the power EI. So again it should be in this form, first theta B, then the unknown, and finally followed by a constant. Second equation. Okay, now in the third equation, MBC. So it is MFBC plus 2EI by L. So again, B is the first term. So it is 2 times theta B plus theta C minus 3 delta by L. Okay, now when you consider BC support, now what's happening here is B is sinking. So what's happening here? In this left support is sinking. Now because the left support is sinking, you have to consider it as minus. Okay, so delta becomes minus. So everything would be same. Theta B exists because there is rotation. Simply support theta C plus, okay, now see here, minus 3. In this delta value, you should take it as minus 0.01 divided by 4 because consider the span also. So again, multiply all these values. So we'll end up with minus 40 plus EI theta B, and keep it as it is, theta B first, again theta B first, theta C second, that is 0.5 EI theta C, then the constant value equal to 40. Okay, then MCB, again same, MFCB, write the formula first, plus 2 EI by L theta B plus 2 times theta C minus 3 delta by L. Okay, so substitute all the values here, and then so you'll end up with 0.5 EI theta B plus EI theta C, 3.75 into 10 to the power 3 equal to 4 minus 40. So it's the fourth equation. So once you get all the 4 equations for all the supports and the members, next is you need to calculate the third point, the third step, that is joint equilibrium equations. So again, in joint equilibrium equations, it is just by seeing this you'll get to know MBA plus MBC is equal to 0. That is the first equation. Then MCB equal to 0. Okay, that is the second equation, second joint equilibrium equation. Okay, so you can see here MBA plus MBC is equal to 0. We have calculated all the values. Equation 2 plus equation 3 equal to 0. Okay, so again keep it in the form EI theta B plus EI theta C. So it is minus 74.17. All right, then MCB is, again keep it in the MCB is only one equation here. MCB is 0, so it is only this. So it is 0.5 EI theta B plus EI theta C plus 55 is equal to 0. So 55 goes that side, becomes minus. Again, these two equations, okay, these two equations, put it in the calc and solve it. All right, put it in the calc and solve both the equations. All right. Okay, so when you solve, you will get minus 26.66 minus 26.66, and theta C is minus 41.66. Okay, this I have shown here another method, that's a manual method of solving this. Okay, once you solve this, see it is in the form of EI theta B and EI theta C. So now that you already know the value of EI, so what you're supposed to do is minus 26.66 divided by EI is 4000 kilonewton meter. So minus 26.66 divided by 4000. Similarly, minus 41.66 divided by 4000. Okay. So once you get your EI theta B and theta C values, next is only direct substitution here. Okay, so MAB, MBA, you'll get, these are the values here. MAB minus 127.5, MBA 72.5, MBC. So BA, BC should be equal opposite. Only then whatever done is right. Okay, so equal and opposite 72.5 plus 72.5 minus 72.5, and MCB is 0. Okay, so now we got all the equations, that is equations followed by the moments, but our main intention, so that is actually I've done in the next page. Okay, you can just check here, sinking type of problem, but they've asked us to draw shear force and bending moment diagrams. Okay, that I've done here. Okay, so support sinking problem. Okay, that part is continued here. So next thing is you have to draw the bending moment diagram. So this free bending moment, that is WL square by 8, and this is WL by 4. So it is 160 and 60. Okay, then we have got the final end moments at the support. So we have checked here, and the support is 127.5, then plus or minus 72.5, and at C it was 0. So mark all of these, and whatever is above is positive, within this line is all negative. Okay, so till here it is we draw bending moment diagram. Next is they have asked us to draw the shear force diagram also. Okay, so because they have asked to draw shear force diagram, everything would be same. Again, split the sections accordingly, the support sections. That is first AB and BC. So first, when you substitute AB, so this is, we have got here 127.5. So it is reaction 127.5, 72.5. Okay, then there's a load here acting 20 kilonewton load span. Okay, you need to find RA and RB1. Again, RB1 because B has is connected for two members, that is BA also, BC also. Will split this. So RB1 plus RB2. Okay, so moment about V is equal to 0. Okay, so we take moment about V. So you're left with RA. Okay, so clockwise positive, anti-clockwise negative. So RA into 8, then minus 127, then plus 72.5, minus, again this is going anti-clockwise, so minus 20 into 82, 4 equal to 0. So you get RA. Similarly, again for the same span, calculate some vertical forces. That is RA, summation V is equal to 0. So RA plus RB1 is equal to 20 into 8. So your RB1 value is 73.13. Then take moment about C. Okay, moment about C is equal to 0. Always take the moments to the farther section of that particular beam. So first we took moment about B is equal to 0. Then now we're taking moment about C is equal to 0. You can take vice versa also. Otherwise, simply you need to solve one more step. That's why I'm taking moment about C first, the farther first. Okay. So now this is RB2 into 4. Okay. Moment about C equal to 0. Okay. Moment about C equal to 0. So RB2 into 4. Then minus 72. Okay. Then minus 60 into 2 equal to 0. So RB2, we got the value RB2. Next, summation V is equal to 0. RB2 plus RB2 plus RC is equal to 60. So RC is equal to 11.88. Now add both of these. RB1 is nothing but it is summation of RB1 and RB2. Okay, I've added both of these here. So I've showed the reaction. This is important. Again, you need to draw all of these. Okay, draw the final beam, and then accordingly it is easy to draw shear force diagram. So here you can see first RA, mark all these values RA, RB, RC, then RA, okay, then there is a UDL, RB and RC. So again, how to draw the shear force diagram, I've already told you in the previous classes. Use calci for this. So let's start with point A. So so RA is going upward. All the upward forces are positive, downward forces are negative. All right. So type 86.67 and 86.87 in the calci. So it is plus now. Okay. So it is like plus 86.87 in the calci. Now downward load, this is acting downward. Okay. So downward means minus 20 into 8 in the calci. So then press equal to, so you'll get minus 73.13. Okay. Okay. So again in the calci it is now minus 73.13. Then how much is RB here? 121. Plus, this is going upward. RB is going upward. So it is plus 121.25. So it is going up like this, 121.25. So it is now plus 48.12. Now there is no load between B and this 60 kilonewton. So this runs straight. Then 60 kilonewton is again acting downward. So in the calci it is now 48.12. Now downward load is minus. So 48.12 minus 60 kilonewton. So it is minus 60. That means minus 11.88. Okay. So minus 11.88. Again, there is no load here. So it is 60 and C. So this runs straight. So now again in the calci it is minus 11.88. Then this is acting upward. So it is plus 11.88. So it comes back to the zero line. So if whatever you do this, okay, from the start to end, where even if you start this, do all the calculation, you should end back to point C. Only then whatever you have done is right. Okay. Then they've also asked you to draw the elastic curve. Now, how to draw this elastic curve is, because it's a continuous beam, it is just done manually. Now see here, Initially it is straight, the beam is straight like this. When the load is applied, what happens? This part of the beam bends, and but eventually, because there is support here, it goes and again joins there. So now this is, it bends like this. Now this bent portion is nothing but basically it is a beam only. This is how we imagine that it might bend because of the loading, but however it has to come to the zero line, that is initial position of the beam. So you can see here this is bent like this because of the load, it bends, but again it joins exactly at B. It stopped here. Okay. It stopped. Now what this load is does here is, because it is pushing like this, now to maintain the balance, any force, any beam, if it has to be in equilibrium, okay, it should be equal and opposite. So AB is bending like this. Okay, AB is bending like this. Because it is bending here, now the beam bends in the opposite direction here. Okay, beam bends in the opposite direction. Now because it bends in the opposite direction, there is a load which pushes down like this. So when this load pushes down, it comes to the BC line. Okay, it becomes straight and it joins C. Okay, this is how you draw the elastic curve of the beam. Now in case there is one more span, supposing there is one more span here. Now how the beam bends is AB in one direction, then BC in another direction. Again it bends in another direction. If it is bends downward, it hogs upward. That is how it happens. Okay. All right. That's all for today. Thank you.